Okay, video lesson number 6. We're going to talk about ionic bonds. Now, a couple key things to remember about ionic bonds is that they involve metal and non-metal atoms. Remember, every atom wants to have 8 valence electrons. That's called the octet rule. Metal atoms will lose electrons to get 8, and in doing so they become positively charged, whereas non-metals gain electrons to get 8, and when they do that, they become negatively charged. Okay? Now, really what happens then is a positively charged ion and a negatively charged ion are, of course, attracted to each other. That's the first rule of chemistry. We put a fancy word on it called the electrostatic attraction. But really, that right there, that attraction is the ionic bond. Now, the key thing to remember out of all things is that ionic bonds are electrically neutral. That means the amount of positive charge must equal the amount of negative charge. Okay? Now, an example, you can see here we've got potassium with 1 valence electron and fluorine with 7. Potassium is a metal, fluorine is a non-metal. So really what happens here is this electron will be transferred from potassium to fluorine, and in doing so, when that happens, potassium becomes positively charged, fluorine becomes negatively charged, and the two attract. Okay, when they attract, though, they become electrically neutral. So that would be the formula for potassium fluoride, Kf. Okay, so we also said that, for example, potassium fluoride is not just 2 ions together. Really, it's a whole network of electrostatic attractions or ions attracted to each other in this, what we refer to as a crystal lattice structure. And in the structure, you can see that we maximize the distance between charges that are the same, like charges, and then opposite charges would be right next to each other. So really we think about it like this. And then we had this idea of the formula unit, right, which is the lowest whole number ratio of the ions. So we said how many of the positive ions are there for every negative. And I said how many of these for how many of those. That's the way we want to think about it. Okay? And so when we think about it that way, and we remember that ionic compounds are electrically neutral, we can then predict what compounds would form between different ions using this thing called the charge balancing method, which is another way of saying the amount of positive charge equaling the amount of negative charge. Okay, so our first example, we have a calcium ion and a chlorine ion. Notice the charge on the calcium ion is 2 positive and chlorine is 1 minus. So I ask myself, do those charges balance? Is the amount of positive the same as the amount of negative? Answer, no, right? There's more positive than negative, so really I'm going to need 2 chlorine for every 1 calcium. And so I write the formula CaCl with a subscript 2. Okay? We then introduce things like the polyatomic ions. Remember, poly means many, atomic atoms. These are many atoms acting together as 1 charged particle. Okay, I called it a package. So it's a package deal. So don't be afraid of these. It's just a 1 plus charge, and then that would be a 1 minus charge. If you just look at the charges, the 1 plus and the 1 minus, that does cancel or balance out. So it's just going to be 1 ammonium for every 1 chlorine. So the formula would be NH4Cl. Okay? In our last example, I've got something like aluminum and sulfate here. So we got 3 plus and 2 minus. So those charges obviously are not the same. How are we going to get that to balance? So we thought about the lowest common denominator between 3 and 2, which of course was 6, right? So I'm going to have a common charge of 6. How do I get there from 3 plus? Well, of course, 2 times 3 gives me 6. And then how do I get there from 2 minus with the sulfate? Of course, 3 times 2 minus would give me 6, okay? The only kicker here is that I have to have parentheses, of course, right, when I'm showing more than 1 polyatomic ion. So you need parentheses, remember, when there's more than 1 polyatomic ion. The other thing you could do is the drop and flop method. So you're just dropping the charges and switching them or flopping them. That also works. Now the last thing we did was write formulas from names, and this seems to be the most challenging thing for students to get, because we're going to combine a bunch of things that we have learned all together into one. Okay, so if I'm asked to write the formula for sodium carbonate, okay, the first thing I got to do is think about this in terms of ions. Okay, so how do I know it's an ionic compound in the first place? Well, if there's a metal and there's two words, it's automatically going to be ionic. Okay, if we've got a metal and a non-metal, it's ionic. And of course, if you see a polyatomic ion, if it ends in ate or ite, it's going to be ionic. Okay, so once it's ionic, I think in terms of ions. And it's very helpful. I strongly urge you to write out the ions before you try to write the formulas, or you're going to make a bunch of silly mistakes. It's going to haunt you all year long. So trust me, write it out, that way you can see it, and then it's just like we did before. So for example, sodium, I need to remember and look on my periodic table that sodium is found in group number 1, right? It's an alkali metal. So that means it has 1 valence electron, okay? If it has 1 valence electrons, it's a metal, it's the left side of the line, it's a loser. If it loses 1 electron, what ion will it form? Well, it will want to form a 1+ ion. So I like to write it like that as Na+, okay? Now I look at carbonate, and I should recognize that it ends in ate and ite. That's a polyatomic ion. So I'm going to look on my list and find the carbonate ion. So that's CO3 2-, okay? So remember, I have that list as a reference, although I asked you to memorize 6 of them. Carbonate was one of them because it comes up so frequently. Okay, and that was just like what I did before. Now I'm asking myself, does the amount of positive charge equal the amount of negative charge? In this case, of course, it doesn't. I'm going to need 2 sodium, right, 2+, to cancel out that 2-. So the formula would be Na2CO3. Okay, next example, aluminum sulfate. Okay, so again, is it ionic? How do you know? 2 words, you got a metal, ionic. One of the words is polyatomic ion because it ends in ate, it's ionic. A metal and a non-metal, it's ionic. So all those ways, okay, you don't have to do all 3, but those are all clues that it's ionic. So think in terms of ions. Aluminum is a group 3 metal, right? So it has 3 valence electrons, it's the left side of the line, it's a loser, so it will form 3+ for its ion. Let's write that out, Al3+. Sulfate, okay, I should say, oh, it ends in ate. That means it's one of the polyatomic ions. Of course, if you look it up, it's SO4 2-, okay? So at this point, I could drop and flop. I could think of the lowest common charge, but the lowest common charge, of course, would be 6. Either way works for me, whatever works for you. So this should be Al2, and again, we're going to need parentheses because there's more than one polyatomic ion, SO4 3. So that's the formula for aluminum sulfate, okay? One last example, I wanted to throw in one that had a transition metal. Okay, now when you see the Roman numerals, remember the transition metals can lose different amounts of electrons. The Roman numeral tells you how many electrons it lost. So in this case, iron 2 means that it lost 2 electrons, so it's Fe2+. Okay, and then chloride. Okay, I have to remember if it ends in I, that's just a regular atom that's gained or lost an electron. It's not a polyatomic one because it didn't end in ate or ite. There are exceptions, but for general, so I'd look for chlorine on the periodic table. It's in group 7. It's on the right side of the line, so that means it's a winner of electrons. If it has 7 valence electrons, how many does it need to win to get 8? Remember, we did this over and over again. Of course, it needs to gain 1. If it gains 1 electron, it's Cl-. Okay? And then once I have the ions, if it's right before my eyes, then I can clearly and easily, hopefully, make the formula using the charge balancing method. Okay, 2+ and 1- doesn't balance, so I'm going to need 2 of the chlorine. So it's going to be FeCl2. So I'm hoping that was helpful for ionic bonds. Good luck. I'll see you in class.